3.1, number 15. Says, find the slope of the tangent line, f prime at A, and equation of the tangent line to f at x equals a. All right, number 15 specifically has f of x as 7 on x and a equals 3. All right, so to find f prime of a, I want to find f prime at 3 using the definition of derivative. I would have h approaching 0 of f of 3 plus h minus f of 3 over h. Now, our particular function is 7 on x, so this can be rewritten as the limit as h approaches 0 of 7 on the x value of 3 plus h minus 7 on 3 itself over h. Again, there must be some kind of hidden factor of h up here to cancel with this, if this is to work out properly. So the easiest thing to do is probably just to combine these two into a single ratio. So I need a common denominator between 3 plus h and 3, and that is their product, 3 times 3 plus h. Okay. Okay. That's the LCD for the numerator alone. So writing that out, the limit as h approaches 0 of, this one does not have the 3 it needs for the LCD. So therefore I need to give this a 3 above and a 3 below. That should give us 21 over 3 times 3 plus h. So now it has the LCD. The first term has the LCD. And now we need 3 plus h to be multiplied above and below so that it has the necessary contribution, causing its denominator to have the LCD. So 3 plus h here and 3 plus h here. That's still all over h. All right, pushing further. Kind of already see what's going to happen here. We'll have 21 minus, combining these two together, 21 plus 7h. I'm going to go ahead and distribute the negative. So negative 21 minus 7h. That's all over 3 plus h, and that's all over h. This h will now be right here, right, in the denominator. So we'll have a limit as h approaches 0 of, putting it all together, 21 minus 21 is 0, of course, and there's our hidden factor of h revealing itself. We have negative 7h left over. And in the denominator, we have 3, I'm going to write 3 first, of course, 3h, 3 plus h. Just common notation to put letters after numbers. All right, nevertheless, the cancellation is what's important here. And we should now be allowed to evaluate, always check it first just to make sure, but should be allowed to evaluate with direct substitution. 3 plus h, and yes, it's true. The bottom is no longer heading towards 0, so therefore direct substitution works just fine, and as h goes to 0 here, as this heads towards 0, clearly we'll have negative 7 over just 3 times 3. So negative 7/9. There is the slope of our tangent line. There's the derivative of this function at 3. Let's finish off the tangent line very quickly. So equation of tangent line should be y equals this slope, negative 7/9 x plus unknown y-intercept for the tangent line. But we know a point which is on this tangent line, the same one it shares with the curve where they're intersecting. And that would be at a equals 3, f of a will then equal 7/3. So this has a certain point that we're aware of. That is 3, 7/3. So we can use the 3 7/3 to fill in for x and y and solve for b. So we should have 7/3 equals negative 7/9 times 3 plus b. So, of course, the 3 and the 9 cancel. So this is negative 7/3. Added over here should give us, what, 14/3? So this implies 14/3 equals b. And now we have our tangent line. We can rewrite this with b plugged in, and that should be y equals negative 7/9 plus 14/3.